My name is Andre Smith. I'm an unrecognized theoretical physicist. I look at the time as a negative one in the past. The current present time is considered zero, and the positive one is the future. It occurs instantly. The right now, then, and will happens at once, simultaneously. For example, imagine a ball. The front of the ball rolls forward, the positive one. I consider the beginning point. The center of the ball is the current, which is zero, and the back part of the ball rolling towards is the negative one, which is the past. It all happens simultaneously, as in quantum physics is the superposition. Imagine time as an integer. The present is zero. The past was a negative one. The future is a positive one. Sounds simple, right? But what if all these integers occur simultaneously? Welcome to the fascinating realm of quantum physics, where time isn't just ticking away, but rather dancing in a superposition of probability. Picture a rolling ball. The forward part of the roll, the beginning point, that's our future, our positive one. The center of the ball, still and focused, that's our present, our zero. The part of the ball that's just completed its roll, that's our past, our negative one. And here's the kicker, it's all happening at once. The roll forward, the pause in the middle, the completion of the roll, they all exist simultaneously. Now imagine our lives playing out in a similar fashion. Every moment, every memory, every aspiration, they're all unfolding concurrently. It's a concept that challenges our linear understanding of time, but this is the world as quantum physics sees it. In the quantum realm, particles can be in multiple places at the same time. They exist in a state of superposition, embodying all potential outcomes until observed. When we apply this concept to time, it suggests that our past, present, and future are not distinct and sequential, but rather they coexist. This notion of time as simultaneous is more than just a theoretical exercise. It could have profound implications on how we understand the universe and our place in it. It could change how we perceive not just time, but reality itself. As an object approaches c, its mass becomes near infinite, as does the energy required to accelerate it. This should mean that nothing can travel faster than light. But imagine an anti-mass particle like a tachyon. Its lowest energy state would see it speeding at IC. But why would this lead to backward time travel? That all hinges on the concept that puts the relative into special relativity. A common tool used to explain special relativity is the space-time diagram. Space-time is filled with events ranging from the cosmically powerful and violent, like the supernova explosion of a distant star, or the mundane, such as the cracking of an egg on your kitchen floor. And these are mapped onto the space-time diagram. This diagram shows as a particle whizzes through space-time, it traces out a world line that maps its progress. Also filling space-time are observers, each of whom has their own reference frame. These observers may see the events that fill space-time occurring in different orders. Observer the first of may see event A, the supernova, occur before event B, the egg crack. Observer 2, however, may see event B happening before event A. Events within an observer's light cone can be linked by a signal slower than light. Events within an observer's light cone can be linked by a signal slower than light. Each event has a light cone associated with it. If event B falls within the light cone of event A, then the two could be causally linked. The supernova could have knocked the egg off the kitchen counter, or maybe the falling breakfast item caused the complete gravitational collapse of the dying star somehow. That's because in the light cone, a signal traveling slower than light can link the events. The edges of the light cone represent the speed of light. Linking an event outside the light cone with one inside it requires a signal that travels faster than light. If event A is in the light cone and event B is outside it, then the supernova and egg-related tragedy can't be causally related. But a tachyon traveling at a speed greater than the speed of light could violate causality by linking these events. To see why this is a problem, consider it like this. Image event A is the sending of a signal, and event B is the receiving of that signal. If that signal is traveling at the speed of light or slower, all observers in different reference frames agree that A preceded B. But if that signal is carried by a tachyon and thus moves faster than light, there will be reference frames that say the signal was received before it was sent. Thus, to an observer in this frame, the tachyon traveled backward in time. One of the fundamental postulates of special relativity is that the laws of physics should be the same in all non-accelerating reference frames. That means if tachyons can violate causality and move backward in time in one reference frame, it can do it in them all. So what's the takeaway here? Time as we know it might just be an illusion. Our linear perception of it, a mere construct. In the quantum realm, time could be a simultaneous swirl of past, present, and future. This is more than just a fascinating theory. It's a radical shift in our understanding of the universe. It challenges our perceptions and asks us to see the world, not as a linear progression of events, but as a tapestry of simultaneous occurrences. In the end, quantum physics doesn't just reframe our understanding of time, it reshapes our perception of reality. It asks us to see the world not as it appears, but as it could be. And in doing so, it opens up a world of possibilities as limitless as time itself.